Today's forecast calls for a low of 300 degrees below zero, with the entire globe covered in ice. A merciless storm of radiation and the eruption of massive volcanoes of ice. Luckily, this isn't the outlook for your neighborhood. It's the weather on Jupiter and Saturn's ice moons. Incredibly, some believe that life might exist on these hostile worlds.
The mantra in our search for life elsewhere has long been, follow the water.
But could life really survive the deathly cold of Europa and Enceladus, the ice moons? Earth's is just one kind of weather. On other planets, there are storms beyond the imagination, climates and conditions that we hope to never see on Earth. But could they happen here? And if so, could we survive? Deadliest space weather. We've experienced some bone-chilling winters here on planet Earth. But what would happen if we woke up to the weather on one of the solar system's ice moons? Humans couldn't survive outside for more than a few seconds. Our oceans would flash freeze. Our cities would become entombed under thick slabs of ice.
We would freeze almost instantly. And there's almost no atmosphere, so there wouldn't be anything to breathe. So it's not a very pleasant place to be.
You would have a frozen, icy world. It's probably not too hospitable to people like us.
Saturn, the sixth planet from the Sun, is known for its iconic rings. The planet is circled by more than 60 moons. Its ice moon, Enceladus, holds one of the most surprising weather secrets in the solar system. At 1/7 the size of Earth's moon, Enceladus looks like a lifeless ball of ice. Temperatures here hover around 330 degrees below zero. Part of its glistening white surface is covered with strange ridges and cracks, some stretching 75 miles across. But when NASA's Cassini spacecraft flew by the frozen moon in 2005, it made a shocking discovery. Giant volcanoes of water and ice. They erupt from a series of surface fractures, sending water and ice into space at 1,400 miles per hour. They look like frosty versions of geysers on Earth.
Enceladus is very active right now. It's got a giant geyser-like plume at the South Pole. And Enceladus is so small with so little gravity that the plume is just giant.
The geysers on Enceladus are an example of what's called cryovolcanism, very low temperature volcanism. This is very different from volcanoes on Earth, where really hot molten rock is being spewed out. The geysers on Enceladus are shooting out water at or slightly below the freezing point.
On Earth, volcanoes and geysers are both driven by heat inside the planet. And it seems to be the same on Enceladus.
The cryovolcanism on Enceladus is caused by water under pressure below the surface and heated to a degree where it can melt. And then the pressure pushes the water and the water vapor and the ice particles out through cracks.
Onboard Cassini, thermal imaging sensors determined that the geyser region was over 200 degrees warmer than the rest of the moon. Scientists suspect this heating is caused partly by radioactive elements inside Enceladus and also by Saturn's gravitational pull.
Enceladus has a slightly elliptical orbit, so sometimes it's closer to Saturn and sometimes it's farther away.
This causes Enceladus to be repeatedly stretched by Saturn's gravity.
Here I have a blue foam ball that illustrates the Earth and a yellow one that's meant to represent Enceladus. I've got a thermometer in each of them, and I'm measuring the temperature of the interior, and I see that both of them are at 70 degrees. So now let me flex Enceladus mimicking the tidal heating that's occurring as it goes around Saturn in its slightly elliptical orbit. If I do this for a while and then measure its interior temperature, I see that it's gone up to 75 degrees, whereas the Earth is still at 70, so it's gone up 5 degrees. Now, of course, the interior of Enceladus isn't foam, it's ice and rock, but the principle is still the same.
On Enceladus, the heat from this tidal flexing causes some of the ice to melt, and the pressurized water pushes through the surface cracks and shoots hundreds of miles into space. The water freezes, and some falls back onto the surface, like snow. Scientists believe the snowfall on Enceladus is so slow and steady, it takes 100,000 years to build up a snowpack a foot deep. But each volcano might last for tens of millions of years, which means hundreds of feet of snow could be piled up in some places, enough to cover the entire U.S. Capitol. This snow layer is made up of tiny crystals finer than talcum powder.
Enceladus might have a coating of relatively young, fresh snow. It'd be fun to ski on it.
This ice storm in space also actually helps to keep Saturn's rings looking so majestic. Though they appear solid from far away, the rings of Saturn are actually made of chunks of rock and ice. And some of that ice is sucked into orbit from the volcanoes of Enceladus. The Cassini spacecraft made another exciting discovery when it made a daring flyby directly through one of Enceladus's plumes. It scooped up icy material that was found to contain hydrocarbons, some of the essential building blocks for life. But so far, no living things, not even microbes, have been found elsewhere in our solar system.
Below the surface of Enceladus, there are chambers of water and maybe even places where there are oceans of water in which hydrocarbons form. And it's conceivable that life has arisen there or could someday arise. Very primitive life, presumably, microbes and bacteria. But it would be very, very exciting to search for evidence of life underneath the icy surface of Enceladus.
Enceladus isn't the only ice moon in the solar system where alien life might exist under some of the most extreme conditions. More than 400 million miles away from Enceladus is the planet Jupiter. It's the largest planet in the solar system, and it has the most known moons. As of 2013, 67 have been discovered. The fourth largest, Europa, is roughly the size of Earth's moon. But when it comes to weather, Europa is an alien world.
Europa is really cold. It's so cold that everything is just frozen on the surface. And in fact, the surface is just a frozen sheet of ice.
Europa orbits about 5 times farther away from the sun than Earth. Surface temperatures range between 240 and 370 degrees below zero.
If you were standing on the surface of Europa, it could potentially be a very scary environment just due to the cracking and creaking and splitting of the ice shell. No life on Earth could ever survive on the surface of Europa.
So what would happen to Earth if it suddenly switched places with Europa? The ice moons of Jupiter and Saturn are home to some of the chilliest weather in our solar system. But what if our own planet's thermostat suddenly plunged to minus 300 degrees, the temperature of Europa? Chicago, Illinois, on the frigid shores of Lake Michigan, once recorded a winter wind chill of 82 degrees below zero. But Chicago has never faced anything as cold as this. Within hours, the Sears Tower, the Windy City's tallest building, would begin to look like an ice sculpture.
Big windows in modern buildings are designed so that the building can flex around them and the glass doesn't get much stress put on it. However, the rubbery seals around the edges break down in very, very cold weather. Today, the wind coming off of Lake Michigan transfers some of its energy to the lake water itself and creates waves. But the wind would not be able to do that once the water is frozen, so the wind would come through even faster.
The frozen windows of the Sears Tower give way, and the brittle steel structure teeters on the verge of collapse. Europa is cold because it's so far from the sun, and it barely has an atmosphere.
There's really no atmosphere to speak of that traps radiation inside and keeps it warm. On Earth, sunlight comes in, is trapped by our atmosphere, and the atmosphere is like a warm blanket that keeps us just right for life.
On Earth, our atmosphere also provides us with oxygen so we can breathe. And it helps protect our planet against one of the deadliest forms of space weather, cosmic radiation. Europa, on the other hand, is constantly bombarded with highly charged particles from Jupiter's magnetic field.
Jupiter has a radiation belt around it the same as the Earth does, but the radiation belt is much bigger.
The average American is exposed to less than 1 rem of radiation per year. Any exposure above 5 rems per year is considered unsafe.
The radiation flux on Europa is over 500 rem a day. So every few minutes, someone would be getting the maximum dose of radiation. The radiation level on Europa would kill us.
Lucky for us, Earth orbits in the sun's Goldilocks zone, a narrow region of the solar system where the temperature is just right for liquid water to exist without freezing or boiling away.
Venus is too hot because it's too close in. Mars is generally too cold because it's too far out. Earth is just right. There's liquid water on the surface, and water vapor, and some ice as well. All 3 phases exist. This is good for the development of life.
Since liquid water seems to be one of the keys to life in the universe, what has scientists so excited about the frozen wastelands of Europa? It turns out this frigid moon holds a deep secret beneath its icy surface. Jupiter's ice moon, Europa, with its frigid temperatures and frozen surface, is truly an alien world. But in 1979, NASA's Voyager spacecraft snapped curious images of the icy moon.
When the Voyager probe went past Jupiter, it saw that the surface of Europa was very cracked. It has these large plates of ice, but you can see that the ice is kind of shifting.
Something had to be causing these surface cracks, but what? 2 decades later, NASA's Galileo flyby mission began to unravel the mystery.
The Galileo probe was able to measure the density profile of Europa and determine that it has a rock core, but that there was a thick layer of something that has the same density as water.
Not only that, but instruments aboard Galileo picked up an electric current flowing from inside the moon. Something scientists wouldn't expect to see on a planet made of solid ice or rock. But electricity is a signal for salt water.
The Galileo space probe was able to measure the magnetic field of Europa. And the magnetic field is what you would expect from a liquid ocean circulating inside the surface of Europa.
before scientists made this amazing discovery, Earth was the only place in the solar system known to have oceans. Now, they believe that a vast salty ocean lies beneath almost 15 miles of surface ice on Europa. The body of water could be over 60 miles deep and contain twice the amount of liquid water of all of Earth's oceans combined.
If you take the total amount of water on Europa, both frozen and in the liquid state, it would be about 2 to 3 times the amount of water on Earth.
What force could create an ocean so far outside the solar system's Goldilocks zone? Here, 500 million miles away from the warmth of the sun, all the water should be frozen solid. It's likely the same force that powers the ice volcanoes on Enceladus.
The gravitational pull of Jupiter on Europa causes Europa to bend and flex, and that movement releases heat inside.
This tidal flexing could produce enough heat to melt Europa's icy interior. The possibility of liquid water oceans in Europa has attracted the attention of scientists on the hunt for alien life in the universe.
Throughout our exploration of the solar system, the mantra in our search for life elsewhere has long been, follow the water. Well, Europa is where the water is.
On Earth, every body of water contains some type of life, even if it's only tiny microbes. In fact, humans most likely evolved from microscopic organisms living in ancient seas. Could there be life in Europa's ocean?
Well, for life, you need water, but then you also need an energy source and the proper organic material. So on Earth, it so happens that pretty much wherever there's water, there's life because you have those 3 components.
Life on Earth gets almost all its energy from the sun. So, where would life find energy on dim and distant Europa? And is there something strange about the water that could bring the search for life crashing back down to Earth? With its deathly cold weather, it seems impossible that alien life could be found on Jupiter's ice moon Europa. However, there are living things that thrive under similar extreme conditions. On our own planet's cold seafloor, devoid of sunlight, creatures find energy and nutrients from hydrothermal vents, which pump out heat and chemicals from volcanic regions.
At the mid-oceanic ridges, where the volcanism is going on, there is abundant life. There's tube worms, giant clams, in an environment which we would believe was completely inhospitable to life.
So, a similar underwater environment might exist on Europa.
Now, if we have similar ingredients like we have on Earth, maybe Europa has the heat and volcanic zones on the ocean floor that has allowed life to evolve and generate.
Or perhaps the essential elements for life on Europa come from a more unlikely place. When Jupiter's magnetic field blasts Europa's surface with radiation, it leaves behind a cocktail of chemicals, including oxygen.
If some of this oxygen is brought into the liquid water ocean, it's possible that the ocean of Europa could have enough oxygen to support the European equivalent of squids and jellyfish and crazy-looking sea anemone and all sorts of bizarre things like that.
But there's one possibility that might make life in Europa's oceans very challenging.
Certainly there is oxygen perhaps making it to the subsurface ocean, but so is a lot of other stuff like sulfuric acid and hydrogen peroxide and things that we normally don't think of as being very conducive to life.
So you might have an acidic ocean in Europa that would be bad for most types of life as we know it.
What would happen if Earth's ocean suddenly turned to acid? Imagine San Francisco's Golden Gate Bridge suspended over an acid bath.
In the presence of an acidic ocean, you'd have a lot of acidic spray and a lot of acidic fog that's just hanging around in that area, and it would eat away at the steel structures and support beams of the bridge. Combining that with the acid eating away at the concrete foundations of the bridge would mean it would be just a matter of a few years to decades before that bridge became structurally unsound and wouldn't be able to be driven on. And it most likely would collapse.
Until scientists are able to get a probe through the ice and into Europa's ocean, the exact makeup of the water will remain a mystery. But the hope remains we may someday find alien life in a most unlikely place: the frozen depths of the solar system's ice moons.